Happy Thanksgiving weekend, monkeys. I'm back and killing off some boredom while the kids are off playing games and the wife is reading a book. Um, Today we're going to jump into a little bit more. First off, I wanted to jump into the fact that I'm going to be replacing the screen with this Geek Pi LCD. This is a 2004. So instead of a 1602, 16 characters, 2 lines, this is going to be 20 characters, 4 lines. So extra bonus, right? So let's just pull this out and have a quick look at it. I'm going to need to print out a new screen holder for it. Just thought about that. So let's pull this out and get it out of the bag. Ooh, right off the bat, what I like is that they included some cables. You can never have enough cables. Can't see that mess in the background where we need more cables. And we'll get it out here. And this does have the IC2 interface on the back, but look comparatively how much bigger that is. A little bit wider and a little bit taller. But you can see that it has the same I2C interface on the back as the 1604. So pretty much a direct swap out. Alright, let me go print a new holder for it so that we can swap it out and make it easy to use. What a mess of a workbench. Okay, well, I've got that new screen holder printing. Let's take just a quick look at what we're going to add in today, which is 3 different LEDs, a yellow, a green, and a blue one, which means that we're going to be using GPIO output 17, 18, and 19. You guys can take a quick look, but it's basically LEDs with the resistors so you don't overpower them, wires, and then just using the common ground bus over here. Alright, let's wait for that holder to print. We'll swap out screens, and then we'll go into a bit more about how we're going to extend what we did kind of last time playing with APIs into today, where we'll probably create a web interface, say, to control the LEDs and keep the messages on the new screen. We'll swap over to this one too, and we'll just kind of see where it goes from there. Okay, during that time lapse, I went and had some turkey and leftover pumpkin pie and took a rest, but we've got a new frame that can hold this new screen. So let's go ahead and get this popped in, because this will be part of today's fun since we just got it. Hey, look, it actually fits. And we'll pop the old screen out and take a look that we've got SDA is yellow, SCL is orange, and we'll just plug those right in over here. And then also take the power and ground and move those over. Alright, well, we got that in place. We got the old one out. Let's hop over and take a look at swapping out the code and making it work. Okay, picking up a bit from where we did last time, let's take a look and just see this is the same script that I did in the last video, and we'll just kind of go over it. We're basically just pulling some APIs and displaying the information on the screen. In this case, though, I just want to show that this is still set to 16.2 for the old 1602 based LCD screen, and let's just take a look what happens when I run it. So you can see that it's actually running just fine. It's just displaying the 2 lines. But let's take a look now and see what happens. Actually go create a new project. Oops. and we'll call it 2004 display test. Fine. I'll just move it out. And in here, let's go ahead and do a new Python script in here, and we'll just call it RPI displays.py. And the reason why I'm going to do that is I'm going to switch Python libraries that is used to drive the display just to make it a little bit easier. I found RPI displays. It's a little bit old, but what the heck, it works right out of the box for what I need. So what we need to do first is just make sure that we have RPI displays installed. So we'll do a pip install RPI-displays. And you can see I've already got it satisfied. So let's start out our new script here, and we're going to do a from RPI displays saying smart.displays import LCD 2004 because that's our new one. We're going to reuse some stuff from our last script, so we'll do from time import sleep. We'll do an import photo 3 for the S3 bucket API call. Import OS to get the environment variables that we set last time, and import requests for the YouTube API. Just to make this easy, we're going to go grab some of the code from last time just so that we don't have to rewrite it all, and we'll just grab all the definitions that we did. And we'll grab that loop and down to our destroy so that it cleans up from itself. Go back over, paste that in. So all of this setup up here of getting the YouTube API and talking to S3 and getting the count from S3 is just like my previous video. Same with the CPU temp and the time now. This loop in here, we're going to have to modify some things because we're actually doing, let's see here, we're actually using a different library that calls things slightly different. So I think the first thing that we're going to do is this MCP output that used to turn on the backlight has now basically switched over to say LCD dot switch backlight, and we'll set it to 1. We do not need this LCD begin anymore. Oops. Which actually reminds me, we never defined the LCD up here from import there, so let's go up here and define that. LCD equals LCD 2004, just like that. And then as we come back down to this loop in here, we don't need to set cursor position anymore. And then the LCD.messages have actually swapped over to be display string. So we're just going to whip through this real quick. I know I could do a find and replace, but what the heck, we're just going to, it's only a few of them. And you can see I already kind of pre-formatted this out.
to have 4 lines now. So we'll kind of go through this. We need to take off these new lines and actually define the line that it's on. Three, line 4, same thing here. 2, take the new line out, 3, 4. So we should see the CPU temperature. We should see it print out a line that says YouTube stats. We should see it print out a line with the number of subscribers. The next one with the number of views. Do a quick sleep for 5 seconds. Clear the screen. Print out S3CDN object count. Here it will do the object count, and it gets that from up here, so it'll print out S3 colon and then the number of objects, and a little string that just says hello monkeys and thanks for watching. So we'll do that and make sure that when we stop it, it says clear. So with that, I guess we should take a quick look at what it actually does and make sure it's working right now. So let's go ahead and run it. Python RPI, and we'll check out and see what it actually does, or if it just dies on us. What did we do there? Oh, well, maybe it would help if we copied over what to do. So let's go add that real quick. And we'll try again, see what happens. Says the program is starting. We've got the temperature, we've got the stats, and all 4 lines are actually working, and it looks pretty good. So let's kind of move on from there. We've got that going pretty well. So let's go ahead and stop the program. Let's do a quick few fixes here, because I noticed when I turned it off, it didn't actually turn off. So LCD clear the screen, and LCD.switch backlight, and we'll set it to 0, which will turn it off. We're going to copy that. Also add it to the destroy, so that when we clear it out in the program, it clears it and shuts it off. We'll go ahead and hit save there. To get into more of what I was first talking about adding some LEDs, let's add in some more messages in here. We'll just copy this block right here. Paste it in. Add an LCD clear over here. And we're going to change some things up, and we're going to make this fancy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Have a, let's see if we can get this. Semi-spaced centered. We'll take 3. Pretty close. And we're going to add that in. Let's just double check that everything is working again. And that everything is clearing out like we set it to, so let's run it again. Oh, before we do that, let's add in another sleep. Sleep 5. Okay, run that again. Well, looks like it's working pretty darn good to me. We'll see if the third screen comes on. Oh, yeah. Well, looks pretty good. Now let's go ahead and stop the program, make sure it all clears out and the screen turns off. Ah, perfect. So that's actually working pretty good. Let's move on to adding in those LEDs that I had you wire in much earlier. To add those in, we're going to need a few more things up here. So let's go import RPI.GPIO because we're going to need that to control those LEDs as GPIO. And then let's come in here and we're going to set GPIO.setMode, GPIO.BCM, and then GPIO set warnings false. Then we're going to need to define a few things out so that we can use them in conjunction with our messages down there. So let's start with defining the LEDs. So LED yellow is going to be on pin 17. LED green will be on 18. LED blue on 19. And we'll need to do LED blue or LED yellow. Zero. This is going to basically set whether it's on or off right off the bat. So LED green SDS equals 0. LED blue SDS equals 0. It's going to define their outputs. So GPIO dot setup and LED yellow GPIO out. And let's just make this a little bit quicker so you guys don't have to watch. And we'll change this one to green and blue, blue, and turning the LEDs off would probably be next. So we'll do GPIO dot output LED blue GPIO dot low. That's right. Turn it low. What am I doing? Doing things out of order. Yellow. Green, blue. Alright, so we've got everything to find out that we're going to need down in our messages, right? So what we're going to want to look at right now is coming down to our loop and then using those LEDs. So let's say right as this first set of messages shows up, we turn on the green LED. So GPIO dot output, and then call the green LED and set its output to high. Should turn it on. So let's copy that statement, and then right after the sleep, let's turn that LED off. Set it back to low, and we'll copy, and we'll leave it alone. After the LCD clears the next one, let's turn on, actually let's make the first one yellow and the second one green. Just because that was my order up there, and that's the way my brain thinks. So we'll copy the green, and we'll turn it off after the sleep is done. Ooh. And then let's turn on the blue one. And then turn it off. That should be it. So, as we can see, we're basically just turning LEDs on as we're showing the description, or showing the strings across the LCD. So we're kind of combining them in. Let's take a look at what it does. Alright, here we go. Has no attribute BCM. Alright, well, let's take a look at that and see what we have going on here, what we missed out on. BCM. Has no attribute. Oh. BCM. That would help. Let's go ahead and try it again. Program starting up. We see those displays. We can see our LEDs swapping. Hopefully you guys can see it. There's the green one. Oh, I have my LEDs in the wrong ones, don't I? Yellow, blue, green. Yep, I swapped the pins around, but either way you guys get the idea of what's going on, and that's how that works. So that's pretty cool too. So now we've got the screens, or the screen, the 2004, working with the LEDs. What's the next step from here? I think the next step from here is introducing a web interface to be able to actually control those LEDs also. So let's go take a look at that. Stop the program here. Alright, let's go make a new project. Again, we're going to call this RPI web server. And we'll move it out. In here, we're going to need to just create a couple of folders. One called static, for static stuff for the web server. Another one called templates, that will house our templates for like the index page that we're going to run through Python and template it out. We're going to make a new file called app.py. Go back to static real quick. Another new file called style.css. In here we're going to put a basic style sheet. Kind of make it easy so that the page looks a little bit better. So you guys don't have to watch me write this out. There's a lot of different online tutorials basically where I got this from that you can go and get them. I'll fix that real quick. Save it. In templates, we're going to go ahead and create another new file going to call this index.html. This is going to be our template for the index page for the website. Again, I'm just going to go grab one. I'll go over it with you real quick. Put it in here. We're going to put in a header and a title, and then down here we're going to actually create some buttons. And this is all templated out through Python for the LED blue, the LED yellow, and the LED green. And you can see they have different actions on them to turn them on and turn them off. We're going to develop a Python app using Flask that has routes to do this. So we just needed the index page to set it up. Let's cruise over to the app.py file, and we're going to start to set this all up and get it going. One of the first things we know that we need from our previous test is the GPIO control, so we'll do import RPI GPIO as GPIO, and now we're going to need Flask. Flask is just a Python web server so that you can run your Python scripts through a web server. Helps out a lot. Go check it out. I'm not going to do a big tutorial on it, but we'll show it to you here. So from Flask, import Flask, and we'll need the render template and request. Oops. Define out our app. App equals Flask name. And then luckily we already defined out all of those GPIO pins, and we're going to go grab all of this right here because we're going to use it again over here. So define out our LEDs, what pins they're on, and now we're going to need to define the index route for the app. So let's do app.route, and this is going to be the index. Define index, and then we need the LED blue status, which I think we can grab from over here too, right? Nope, we didn't do those yet, but we'll type it out once. LED blue status equals GPIO dot input LED BLU. We'll copy that and we'll do it for each one of them. Change this one to yellow. Do this one for green. And then we'll need to call the template. Template data equals, go into an array, title, and we'll say GPIO output status, and then LED blue, LED blue status. And we'll do that for each one. Change that one to yellow. And this one to green. Got the template done. Let's return. Render template index.html and template data. Okay, so there's our index route. Now we need to handle a route for each LED and the action that it's going to take, whether it's on or off. So let's go ahead and define that out. So we're going to need to do an app.route. And this one's going to be, just like I said, device name / action. And then define the action as device name action. And now we need to do some if statements depending on which LED it is. So if device name equals LED blue, and use the actuator equals LED blue. And we'll do one of those. For yellow and green too, so we'll change this to yellow. Green. And now we need to define some actions. If action is on, then turn it on. So GPIO output actuator GPIO high. And then same thing if it's off. If action GPIO output actuator GPIO low. Okay, so now we need the status. Equals GPIO input. And we're going to need to do that for yellow and green. So we got that, and template. Data equals going to the array, and we're going to need the stats, so we can actually copy that from up here. Blue, yellow, and green status, and then return the rendered template. And template data. So now we've defined our route for index, and then we defined a route for our different LEDs and the actions of on and off on each one of them. So let's finish this off. App.run host. And we'll just set that to everything. Port. We'll run this on port 888, and might as well turn on debug because something's going to go wrong. there we go. So basically what we set out is the GPIO control of the 3 LEDs that we did before. And this time we have a route that's going to show us basically the current statuses, and from our templates give us a button to turn on and off, which calls these routes, which is LED name and then the action of on or off. So let's take a look and see what this does for us. Oh, we need to move folders over. Impert, yep. Someone saw that and was screaming at their screen at me. How about now? No module named RPU. I was going too fast on this one, guys. Just trying to keep the time down on for you. And third time's the charm. Oh, it says we're running. Let's flip over to our browser. Here we go. We've got a nice website with the button for each one of the LEDs, and we can see if we click turn on. We can see the LED turns on for the blue one. We can turn it off. Turns off. Test yellow real quick, and test green real quick. Yep. We can turn them all on, and the website is showing us the status. So this is a website using Python GPI control. So that gives you guys some ideas of what you might actually be able to do. So let's just add one more thing as a quick bonus in here. We jump over to our index template in the body here. And this is only if you guys happen to notice that there's an Arduino cam hooked up to the development Raspberry Pi now. So H1 Pi camera. I had this sitting around from my 3D printer and a previous review that I did, and my other one was actually a little bit better than this one, so I hooked it up to my DevPi, and I installed Motion onto the DevPi, which is basically allows you to stream the camera or use it as like a security camera. I turned off all recording, it just is streaming on a different port. So if we go HTTP and the IP address of my DevPi, 10.1.67, and call port 8081, add a title, camera. We can allow full screen equals true, and set a height 728 pixels, and we'll do width 1280. Add a style equals border of a pixel, and solid black, and in the iframe. Hit save. Hop back to our browser, hit reload, and we can see that we have the camera from the Raspberry Pi pointed at it, so that we can actually watch directly on screen now. So there's the blue LED. That one's hard to see, but it's on. And the green LED, they're all on. But what this does is it allows me to go sit on my couch and play while the Raspberry Pi board sits down in the basement. And I can also see the screen. Alright, so guys, we went through a lot today, having some fun. I hope you guys learned something, and we'll continue on with your own projects. Let me know about them. Let me know what you think is fun, and we'll see what we can do on the channel. Alright, I hope you have a great rest of your holiday weekend, and see you guys later.